Good morning, class. Today we're going to discuss the third law of Newton's motion, but I want to first review the first two laws we talked about last week. The first law we talked about last week, and the second law we talked about yesterday. So who can give me an example of Newton's first law of motion? Bob? That's correct. When you have a vehicle, for Newton's first law of motion, when you have a vehicle that is driving at a high rate of speed, and the driver may be in an accident or stop abruptly, what happens if that person does not have their seatbelt on? That's correct. The person may go through the windshield or get thrown into the dashboard. And what is that called? What's the law that Newton named that? That's correct, the law of inertia. Okay? So Newton's first law is an object at rest will remain at rest unless acted on by an unbalanced force. An object in the motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force, which is, this law is often called the law of inertia. And then yesterday we continued our studying with the second law of motion. And can anybody tell me what the second law of motion is? Betty? That's correct. According to Newton's second law, acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. And so exactly what does that mean? It means that every day we are in some way or another using Newton's second law of motion. So everyone knows that heavier objects require more force to move the same distance as lighter objects. And how did he write that? Does anybody know the formula he wrote that with? He wrote that F equals m times a, which is force equals mass times acceleration. And this brings us today to Newton's third law of motion. Newton's third law of motion states that every action there is an equal and opposite reaction. And what we're going to do to help you better understand that is we're going to talk a little bit about how a rocket is launched. A rocket that is launched is basically using Newton's third law of motion. So, in order to understand this a little better, we're going to talk about rockets. Now, when a rocket takes off, and here we have a rocket, and we're going to conduct a little experiment later to give you a better example to help you understand this. The rocket's reaction is to push down on the ground with the force of its powerful engine. So when you see all that smoke and fire and everything billowing about, that is the force that is pushing down on the ground. Okay, so it pushes down on the ground with the force of its powerful engines, and the reaction is that the ground pushes the rocket upwards with an equal force. So today, what we're going to do is we're going to build our little rockets. We've already built these, okay, out of our little patterns that they gave us, out of a film canister here, and we made the wings and everything. So now let me talk a little bit how this is going to work, okay? So as I talked about, when a rocket takes off from the launch pad, it is basically enacting the third law of motion. So as the rocket leaves the ground, because of Newton's third law of motion, which states that every action, there's an equal and opposite reaction. The thrust of the exhaust pushing against the launch pad is the action. The rocket launching into the air is the reaction. Does everybody understand that? Okay. So in modern rockets, the thrust is created with rocket fuel. Rocket is made of a propellant and an oxidizer. Burning the propellant with the oxidizer produces a lot of very hot gas that expands. The hot gas is forced through a nozzle and rushes out the back of the rocket at high speeds. So as part of our experiment, what we did was we took this film canister, and of course they gave us some cutouts to make it. Let me just give you a brief idea to the audience at home that how we did this. So they had us build our own little rockets out of a film canister, and we make sure that the film canister, the bottom with the lid, is pointed downward because that's going to be where we launch it from. So we start it out like this, and we make our own little rocket. Okay? So this is how the kids made their rockets, and this is the end result right here. So what happens is we take off the cap, off the end of the film canister, and like a burning fuel in a rocket, what we have is we have our Alka-Seltzer and our water, and by placing we put 1 teaspoon of water into the canister, and then we place our Alka-Seltzer tablet into the water, and the Alka-Seltzer in the water will give off gas to create the thrust. The Alka-Seltzer is made of citric and sodium bicarbonate, and the citric acid is a weak acid, and the sodium bicarbonate is a weak base. So whenever water is added, the two will react, which will make the bubbly or the effervescence, the bubbly that happens when you put Alka-Seltzer into water, and they'll release a gas. Since there's no way for it to escape, these tiny gas bubbles will build pressure inside the film canister, and the pressure will cause the canister to pop open and produce thrust against the ground, causing the rocket to launch into the air, which is Newton's third law. So what we're going to do is I'm going to put my 1 teaspoon of water in here. Alright, get that in there. Okay. So we got 1 teaspoon of water. I might put a little more because I spilt some. And then what we're going to do is I'm going to put my Alka-Seltzer tablets in here. Now, usually we would go outside and do this, but because it's windy, we're going to do it in here. And let me turn on the lights. And turn my camera around here. So, what we're going to do is I'm going to put my tablets in here, pop on my cap, and then we're going to step back and we're going to watch the rocket launch. And I said it would take 15 to 20 seconds. And what was happening is those bubbles are building up pressure in there. And pretty soon, because there's no place for, there it went, there's no place for the bubbles to go, it launched the rocket. So if we had been outside, because that hit the ceiling, if we had been outside, who knows how far that would have gone. But on another day, we'll continue, we'll experiment more with that. So now, does everybody understand Newton's third law of motion through that experience? So for every action, there's an equal and opposite reaction. And that is Newton's third law. And those are the 3 laws of motion according to Newton. So in conclusion, we learned altogether that there are 3 laws of motion. The first law being the law of inertia. The second law being that is an acceleration is produced when force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. And then our third law of motion, for every action there is an equal and opposite reaction. So today, when you are out playing with your friends on the playground, think about those laws of motion that you may be exhibiting through play, whether it's pushing on each other, whether you're pushing yourself up off the ground, whether you're outside pushing a wagon around or whatever. Just remember that those are Newton's 3 laws of motion. Okay?